Hello, Justin. Hey, Chris. Good morning, Sarah. Did we do the pre-work? I'm sorry I sent it a little late. But since it was so short, I thought, it's just I didn't want you guys to do it yesterday and then do it today because then you could forget. Like this way, it's fresh in your heads, right? Initial impressions, how crazy is she, right? Isn't she like, oh, you don't have to turn it in. No, you just got to watch it and like think about the questions because we're going to answer the questions together right now. Good morning, Atin. What did you think about her? Kind of cool. It was very impressive. Pretty cool. Anito, amazing. Let's start around 10:38. Okay. So there's only 7 people in the chat. It's kind of sad because we're starting later than normal. I don't know where everyone is. The comment section was nice. I actually haven't looked at the comment section. Let's see. Me, I wish I had friends to harmonize with. Me learns how to harmonize with myself. My dog is so confused right now. Don't even be trying to hypnotize me with your elven magic, woman. This is the siren song that history warned us about. YouTube algorithm never ceases to amaze me. This just made my bird really happy. He's stretching and singing to the songs. I don't know what's going on. Oh, that's cute. That's cute. In my choir back in the day, we actually learned how to sing with an overtone. Like the way she's doing or in a different method, Ainaba. Sarah, maybe they are still doing this. It took 25 minutes for you. Oh no. Oh no, well, I thought the first part, just playing with the generator, took like 3 minutes, right? You just got to play those frequencies. Right? A very similar method. Yeah, it's extremely difficult, right? I think she's probably one of like 5 people in the world that can do it to that kind of level, where she can really amplify the overtone to be louder than the fundamental, which is ridiculous. Never heard of that happen. Okay, so it is 10:39. We are 5 minutes in. Let's begin with the actual thing, right? So for those of us who are joining us, hopefully, whether you're with us live in the chat or if you're watching this sometime later at home, you should have watched the video. I'm going to link it. I'm going to actually just post it in the comments. So if you haven't done so, you can watch it, all right? And the basic notion here is I want to answer a pretty basic question, right? Because yesterday we went over how we have musical terms and we looked into the physical terms that they kind of correspond to, right? So like volume or dynamic level or loudness corresponded to the amplitude of the wave, right? Of the sound wave, and pitch, or like the note that you hear, corresponds to the frequency, right, of that wave. But we had one more musical term, and it's called tone. All right. Good morning, Itamar. Right. So tone is really important because that's exactly what is tone, right? Tone is like the quality of the sound. Like if I sing a 261 and Itamar sings a 261 hertz, and Ainava taps back into his choir days and also sings a note at 261 hertz, right? That's all the same note, right? But they should all sound different. You should be able to tell uh, if it's like a blind curtain behind all of the singers, like who is singing which note, because their voices all sound different, even though they're playing the same frequency. And that is something we know as tone. Okay? All right. So before we get into that, I have to pour this cup of tea. Yum, delicious. Oh, it smells so good. Yum. Today's gonna be a great Wednesday. I can feel it. Oh, that's bitter. Maybe I let it steep for too long. I definitely let it steep for too long. Maybe this won't be a great morning, huh? Okay, so today's Wednesday. It's our second day of school, but we had Monday off. Hold up, I need to pour some water in here. Okay, so remember that we had this thing called resonance, right? And it's when an object, right, vibrates at its natural frequency. Right? Why is that true? And why does it only vibrate at its natural frequency, right? Well, because when I want to vibrate at, well, take the example of a string, right? So a string can only vibrate at a frequency that gives a wavelength of 2L, a wavelength of L, or a wavelength of 2L over 3, etc., etc. Like, Mr. So, you just gave me the wavelength. It's not the frequency. Well, once I have the wavelength, I know the frequency once I know the speed, right? Because V equals lambda times frequency. So the frequencies that you're allowed to vibrate at is just V over lambda, right? Which is equal to Vm over 2L. Okay, so, but my lesson yesterday was kind of a teeny bit of a lie when I said, well, I think I kind of implied that there's only one natural frequency per object, and that's not particularly true, right? For the string, for example, has a lot of natural frequencies. Like it can vibrate at this one, it can vibrate at this one, and it can vibrate at this frequency, right? Because all of those frequencies correspond to a wavelength that still satisfy the boundary condition where I need a node on either side, right? So in reality, there are many frequencies that you can resonate at, but still there are specific ones, right? It's still like a very small percentage of all the possible frequencies you can vibrate at, right? That you can be vibing. And that's why they're special, right? And why is that? Because not only certain frequencies give you a node-node condition that's required. Now, while other objects like wine glasses and vocal cords are they're not as simple as a string, the same concept applies, right? In that there are many different frequencies that you can resonate at a configuration, right? So just like how does my voice work, right? It works just like the wine glass. Remember, like the more water I poured in the wine glass, I changed its set of natural frequencies. Notice I used the plural, right? At each water level, there is a whole series of natural frequencies that the glass could resonate at. I do the same thing in my vocal cord by altering the tension and the size of the air column in there. You're changing the size of it, and you're changing the resonant frequencies of your throat. How do I agitate it? You obviously don't hit your throat, right? When you pass air through your vocal cords in a certain way, it'll cause it to vibrate, just like blowing on, just like this, right? Just like, right? Just by blowing air through here, it'll cause the thing to vibrate. Same thing, passing air through your vocal cords. It'll also vibrate that way, and that's how it resonates. But let's get back to tone, right? So in actuality, because all of these frequencies, the fundamental and all of the harmonics, the first harmonic, which is the second mode, the second harmonic, which is the third mode, right? Since all of those are allowed, when an object is vibrating, it actually does vibrate at the fundamental and all of the harmonics above it. And it becomes a superposition of all of those. And why you only hear the fundamental is because it is the largest amplitude wave of all of the harmonics, right? So it's the loudest one, and that's why it's like the note that you hear, you know? Even though like you are singing 10 notes at once, right? I can sing all the way, right? When I sing a note, right? I'm actually singing that note. I'm singing the one an octave above it. I'm singing the second harmonic, the fourth, fifth, sixth, seventh, eighth. But all of those upper harmonics are at such a low amplitude, you don't really hear them, right? And that's what tone really is, though. Okay, tone is the ratio of all of the harmonics, right? So if like your lower harmonics are really strong, right, it gives like a really like round sound, right? If your upper harmonics are really strong, your voice can sound really tinny, right? And like really sharp. And yeah, and every person, right, when they sing a note, has a different ratio of amplitudes, like using the fundamental as like the loudest one. Yeah, and that's why everyone's voice sounds different, and that's why a clarinet sounds different than an oboe. That's why two clarinet players even sound different from each other, right? Because just the way their mouth interacts with the reed and the mouthpiece, like they're emphasizing certain overtones more than others, right? So the big idea with the video from Ana Maria Jefe is there's a huge misconception when people say like, oh, like I can sing 2 notes at once. Well, guess what, buddy? Everyone sings more than 2 notes at once. Everyone sings like 10 notes at the same time. At the same time. At the same time, right? Like when I sing a note, I'm singing that note and the entire overtone series above it, right? And that's like the cool thing about it, right? So what is she doing that's so special? It doesn't, Itamar, it's infinite. But the thing is, like, once you get above probably like the 7th overtone, or the 7th harmonic, they're so quiet and You just don't really hear them. Do you remember yesterday where we found out if you double the frequency that you go up an octave? Do you guys remember that? Let me know if you do. Yeah, Chris remembers, Ethan remembers, Atune, Justin, yes, Sarah. Cool. So I hope that when you were doing your harmonics exercises, right, that when you went from 100, 200, 300, 400, 500, 600, 700, 800, that you should have noticed the jump from the first to the second overtone is an octave. And then you have one more note, which is 300. And then when you hit 400, you hit the same fundamental, but 2 octaves above, right? And then you hit 5, 6, 700, and then you hit 800 again. And then from 800, you get 9, 10, 11, 12, 13, 14, 15, 16. You hit 7 notes before you even hit the next octave, right? So what that's saying is the higher up in your harmonic series you go, the closer the notes become, right? Just due to the nature of like doubling is an octave, and each harmonics are just multiples, right? And you can fit more multiples like the higher up you go in one octave. So I thought that was pretty cool. And what you heard when you played with your synthesizer, right, as you went up in the harmonic levels, I could play it for you on my instrument, but let me check my channel. Yeah, 128 subscribers. No, I'm doing an instrument reveal at 200 subs, okay? So not really doing anything right now. So that's like the really cool part, right? Like you can hear like the harmonic series, and everyone, when they sing a note, actually sings like a bunch of harmonics. So what is Anna Maria Hefele doing that's so special? She alters the structure of her throat such that all of the harmonics do not resonate. She basically makes them anti-resonant. She alters it. She alters the natural frequency of her throat to only emphasize one overtone and one harmonic. And all the others are just not allowed. She creates new overtones, right, and stuff like that. So not new overtones, but she alters the shape of her throat to create different boundary conditions so that if she only wants to hear the fundamental and the fourth harmonic, she will alter the shape of her throat so the second and the third and the fifth and the sixth and the seventh do not resonate at all. In theory, sure, you can kind of understand how that works, but if you actually start to think about what I can do to my throat to cancel out 7 out of 8 overtones, I have no idea where to even begin with that. I mean, Ainaba, if you're interested in like relearning how to do that, like the rest of her channel does have some lessons on how to do it, but yeah. She has a tutorial, and I've tried it, and like, I do not have a talent for polyphonic singing. All right, I'll just say that. All right, but here, what I really wanted to get at today was just that misconception, right? That, oh, she can sing more than 2 notes at once. Dude, everyone sings more than 2 notes at once. She is unique for only singing only 2 notes, while the rest of us sing like 10, right? And that's super cool. I really like using this as an example for a lesson because it combines a lot of things. It combines things about standing waves, right? Where you learn about when you can like apply like the different harmonics. It talks about resonance and natural frequencies, and it's a great example of interference and superposition. Like our voices are, whenever we sing, are interferences or superpositions of the fundamental note we're singing and all of the harmonics, right? And that's what gives each of our voices a unique sound, because we are all singing and outputting interferences of like 10 different notes, but at different ratios, and that's why they kind of sound different. Yeah. All right, with that, I will leave you. Tomorrow, we are going to be talking about 2D waves and no longer 1D waves on strings, okay? And next week, we're going to leverage this stuff we're learning about 2D and apply it to light waves, all right? Shining lights, okay? Do I even have 200 students? No, I only have 108, and I still have 128 subscribers. Okay, so I feel like 200 is within reach. And if you're going to be a non-believer, if you're going to be a hater, then you can just leave the channel, Ainaba. We don't need your kind of negativity here. All right, so slap like, and because there's only 4 likes. Thanks, Itamar. That I really appreciate it. All right, 200 subs, instrument reveal. Okay, 300 subs, extra credit reveal. All right, 400 subs. I don't know. I'm not even gonna reach 200, so there's no point. Have a great day, and I'll see you guys tomorrow. Happy Wednesday, happy hump day, and goodbye.